Have you ever looked at a tiny seed and wondered how it knows exactly how to become a giant tree, or how your own body knows how to turn a piece of bread into energy for your brain? This incredible magic happens because of tiny workers called proteins. They are the most important tools in the toolbox of life. Think of them as very long strings of beads. Each bead is a different amino acid, and there are 20 different types of these beads in nature. You can imagine them like an alphabet of 20 letters. When you put these letters together in a certain order, they form a word or a sentence. In the world of biology, this sentence folds up into a very specific three-dimensional shape. This shape is everything. If the protein is shaped like a key, it might open a door in a cell. If it is shaped like a pair of scissors, it might cut up food in your stomach. These shapes have been perfected by nature over millions of years through a very slow process called evolution. Nature is a great designer, but she is very slow. She takes her time to get things just right. However, we are now living in a time where we face problems that cannot wait for a million years. We are facing plastic in our oceans and too much carbon in our air and diseases that need new cures. We need these tiny protein workers to do new jobs, and we need them to start right now. This brings us to the surface concept of protein engineering. At its simplest, this is the art of changing the order of the beads on the string. If we can change one or two letters in the alphabet of a protein, we might make it stronger or faster. We might make it able to eat plastic or capture carbon. For a long time, this was very hard to do. It was like trying to write a beautiful poem by changing letters at random and hoping for the best. Scientists would try 100 different combinations, and maybe only one would work. It was slow and frustrating work. But recently something has changed. This change comes from the hidden assumption that science and art are completely different worlds. Many people believe that science is only about cold hard facts, while art is about creativity and imagination. But if you look closely at a scientist designing a new protein, you will see an artist at work. They are using their imagination to dream of shapes that have never existed in nature. They are looking at a landscape of possibilities that is billions of miles wide and trying to find a beautiful path through it. The advent of artificial intelligence has given these scientific artists a powerful new brush. AI can look at the patterns of the protein alphabet and suggest new shapes that a human brain could never imagine. Before AI, the success rate was tiny. Now we are seeing that 20 out of every 100 designs might actually work. This is a massive leap forward. It means we are no longer just waiting for nature to give us a push. We are taking the lead. This reveals a structural pattern in how we solve global problems. Usually the most advanced technology is kept in just a few places in the world. But the problems we face, like pollution or climate change, are everywhere. There is a pattern of relying on a small group of experts in wealthy countries to save everyone else. But what if we broke that pattern? What if we created a community of designers in places like Latin America or Africa? This is about building a critical mass of people who can look at the specific problems of their own countries and use these AI tools to create local solutions. It is about moving from being a consumer of technology to being a creator of it. When scientists come together to share their knowledge, they become bigger than the sum of their parts. They can explore the untapped terrain of biology. There are trillions of protein shapes that nature has never even tried yet. We are like explorers standing on the edge of a vast new continent. We have the maps and we have the tools to navigate this landscape of sequences and structures. We can reframe our entire perspective on the natural world. Instead of seeing nature as a finished product that we just have to live with, we can see it as a partner. We can give nature a little push in the right direction. We are not trying to replace nature, but to help it catch up with the modern world. This application of creativity to biology is how we will solve the most pressing issues of our time. Think about your own daily life. Think about the plastic bottle you held today or the air you breathed. Somewhere in a laboratory, a designer is working on a protein that could turn that bottle back into earth or keep that air clean. These scientists are looking at the same alphabet of 20 letters that has existed for billions of years, but they are writing new stories with it. They are finding beauty in the geometry of molecules. They are proving that a playground for creativity can exist inside a test tube just as much as on a canvas. This work is deeply human because it is driven by a desire to benefit society. It is about using our brains to protect our hearts and our homes. We are learning that the most powerful thing we can do is to come together and dream of things that have never been seen before. We are navigating a space that is full of hope and potential. The more people we educate and the more communities we build, the faster we will find the answers we need. We are no longer just watchers of the world but active participants in its design. We are taking the toolbox of the cell and adding new tools to it every day. This is a journey that requires patience and courage, but the rewards are immeasurable. We are building a future where our technology is as elegant and efficient as a living cell. We are moving toward a world where we can fix the mistakes of the past with the wisdom of the future. It is a slow and careful process, but the momentum is growing. Every new protein shape discovered is a victory for humankind. Every new scientist trained is a light in the dark. We are part of a global conversation about what it means to be a caretaker of this planet. We are realizing that the language of life is something we can learn to speak fluently. And once we speak it, we can start to heal the world in ways we never thought possible. If you had the power to design a tiny invisible worker to solve one problem in your own neighborhood, what specific task would you give it?